Thank you, Woody. Woody's presentation, Melodies and Jonathan's, gave a good idea of the vast array of data being collected. Then, of course, these data have to be integrated, managed, made interoperable to be able to be used, and especially the big challenges with biodiversity observations, species observations across the globe, or even within a protected area, to be usable. And Donald Hobern from Global Biodiversity Information Facility will talk about how these vast arrays of data sets can be compiled together to provide evidence for biodiversity.
Thank you very much, Erin. It's a pleasure to be here this morning. We've talked already in the previous presentations about opportunities to capture a variety of information about species, not just where they're found at a particular time, but also movements and other aspects. And this points to the fact that biodiversity is, in many ways, much more complicated than, for example, climate. We're talking about a complex system where, although we talk so freely about biodiversity and talk about it operating at multiple scales, the ability for us to measure just a few things and declare that that is a measurement, a variable for biodiversity, is immensely challenging. And that becomes clear to us if we think about all of the interconnected web of things that we wish we knew about all organisms to understand not only their distribution and abundance, but also the role they're playing within ecosystems, the dependencies between species, what is going to be required to maintain healthy populations or better populations of those species. So this represents just a snapshot centered on one species of the kind of information we need. And if we think about that, we realize just how fragmentary and sparse the evidence we have for biodiversity in a form that we can use for large-scale monitoring and planning really is. We've already touched in the last couple of presentations on some of the sources of information. The two presentations from Melody and Woody have focused particularly on how we now capture information about the current state of biodiversity, particularly within protected areas. If we want to understand the context of this, we also wish we could have access to whatever has been recorded in the past about these same species and these same areas. So in an idealized world, we would have access to all of the information from collections, field observations, ecogenomics, remote sensing, in some kind of interoperable way. And this information would be made available to support all kinds of uses. Today we're thinking particularly about understanding protected areas and the changes in biodiversity within them. But if we can organize this information well, we can answer a lot of other questions in relation to studying those organisms and also other areas of sustainability. The work of the meteorologists and the climatologists in bringing together primary data and then organizing it to give us our current understanding of the world's climate and changes of climate has been already referenced. Any of you who are interested in that process, I strongly recommend this book. But the key thing that we can see there is an enormous amount of work to take often information that was collected using different devices over a long period of time with enormous gaps in the networks of measurements and turning those into modeled surfaces across the whole planet that allow us to see the best estimates of the state of the climate at particular times and places. And if we want to understand for all parts of the world and within and without protected areas, exactly what has been going on and what the changes in state are, we need to think about how we can get as close as possible to that. We have a large array of activities and organisations that play their parts in this space. And I think, as was suggested by Woody towards the end of his talk, we've got to be thinking about efficient ways for all of these to work together and to plan a coherent delivery of fundamental information. We have a lot of activities that are collecting primary data. We have activities such as the organisation I represent, the Global Biodiversity Information Facility, that are trying to pull together globally coherent views of particular aspects of this information. All of the evidence we have for species in time and space, better organisation of all the names that have been applied to species, relevant traits for species, and obviously the genes, etc. But on top of that, we need to go beyond all of these point observations and get to the same stage that the climatologists have been working on, which is representing meaningful variables in time and space that can indeed support subsequent levels. The research and the coordinated assessments that may be needed that can then feed on up through IPBERs, through the conventions, and ultimately support national governments in their decisions. This is a complicated task, and the biggest challenge of all is that although we're all committed to seeing the same outcomes, we all have organisations that are driven by different agendas, different priorities, and already have existing obligations. For the promise to give us guidance as to how we can work together, or at least a challenge to work together, to deliver the kind of information systems that are needed, is really essential. I want to focus on three areas, just very briefly, as the ones where we need to give more attention. This today is the map of 500,000 points of evidence that are currently available through GBIF. And as you can see, there are reasons that are associated purely with the dynamics of building our own international network here, which reflects some of the gaps. But still, the information that is available does not cover the Earth's surface, it doesn't cover the oceans, it doesn't cover particularly the regions of highest biodiversity as well as we would wish. How do we ensure that all future observations that can give us evidence about species and all historical information about species can be brought together in a form that can be combined like this and then used for further analyses? Secondly, as we do this, how are we going to manage these data? I think it's absolutely essential that we make as much of this information freely open as possible for anyone to be able to reuse and analyse. But our biggest challenge in this area right now is that much of the information is mashed up for others to use, but is not stably managed. If somebody today fixes information about a particular specimen through the GBIF network, there's no necessary connection back to the original data sources to fix the problems, and it means that people keep finding the same issues. What we actually want is to move to a point where we treat all of this essential information as part of a global knowledge resource that we all manage together, and if we find that a specimen record or an observation seems unlikely, we can annotate it and fix it together, and nobody else has to come back again and find the same problems. How do we get to that point? We need research infrastructures to help us. And lastly, coming back to variables, I think we need to carry through this work of understanding, out of all of this information, how we create the necessary variables that will help us to make the decisions and understand change in time and space. What do we need to do to model on top of all of these point data to produce continuous surfaces at the highest possible resolution to see the patterns in biodiversity? And then from that, how do we turn them into a small set of practical, achievable, realistic indicators that are spatially explicit and can be used in monitoring and planning and response, particularly around protected areas, but also through the rest of the landscape? Thank you very much.